let's balance this redox reaction in basic solution. If we go through the same steps, there's just one additional step at the end that we'll see. Okay, we need to assign oxidation states for each of the atoms so we know what is oxidized and reduced. So bromine here is an element, is an atom, and so its oxidation state is just its charge. MnO4 minus, oxygens are -2, so that's a total of -8. So Mn has to have a total of +7 to give -1 overall. So that means the oxidation state of Mn is +7 since there's only one. Okay, here, oxidation state of oxygen is -2. We have a total of -4 for the oxygens. So that means the manganese has to have a total of +4 to give 0 the charge on the molecule. So each manganese, since there's only one, will have to be +4. And bromate ion. So we assign oxygen first. So oxygen is -2. That's a total of -6. So total for bromine has to be +5 to give a -1 total charge on the molecule. So the bromine is +5. So now we have our oxidation states. So we can see that bromine has gone from -1 to +5. So it has lost 6 electrons. Manganese has gone from +7 to +4, so it has gained 3 electrons. So bromine has lost electrons. That's the oxidation. I'll write it. Okay, that's the oxidation reaction. And now I will assign how many electrons are required to do this. So bromine has gone from -1 to +5, so it's lost 6 electrons. So the first thing I want to do is balance the atom that is gaining or losing electrons. So here bromine is already balanced 1 to 1, and so a total of 6 electrons have been lost from the bromine atom. Okay, so now I'll write the reduction reaction. So I have MnO4 minus, and it is going to MnO2. And so this manganese has gained 3 electrons. So each manganese has gained 3 electrons, so make sure the manganese is balanced 1 to 1 here. So I can write +3 electrons. So manganese has gained 3 electrons to go from +7 to +4. Okay, now I can start balancing the other atoms besides oxygen and hydrogen. So I've already made sure the bromine's balanced. Manganese is balanced, so now I can balance the oxygens. So I have 3 on the right, so I need 3 oxygens on the left. And remember, oxygens come from water in solution. Let's see, I've got 4 on the left here, 2 on the right, so I need 2 more oxygens on the right. So oxygens come from water. So now I can balance the hydrogens. So I have 6 on the left. I need 6 on the right. And I have 4 on the left here. So I need 4 on the right. There. So now this is in basic solution, so I have one additional step. I have to cancel the H pluses, because in basic solution we have OH minuses in predominance instead of H plus for acidic solution. So for basic solution, I'll add enough OHs to cancel the H pluses. I will add enough hydroxides to each side of the equation to cancel the H pluses. So if I add 6 OHs to the right, I need to add 6 OHs to the left, so that hydrogen and oxygen stay in balance. So now these will combine to form waters. So the H plus will react with the OH minus to form water. So I'll have 6 waters here instead of those 2 species. And let's see, I have 4 H pluses here, so I'll need to add 4 OHs to the left and the right side. So don't forget to add them to both sides. So this will react to give 4 waters. Okay, now everything should be balanced. I'll double check. First, the charge. I have 6 plus 1, 7 minus. So I have 6 minus, 7 minus. Good, so I have 7 minuses on both sides. I have 1 bromine. I have 6 plus 3, 9 oxygens. So that's 3 plus 6, 9 oxygens. And I have 6 plus 6, 12 hydrogens. So that's 12 hydrogens. So everything balances for the top reaction. For the bottom, I've got a total of -3, -4 on the left, total of -4 on the right. 1 manganese. I have 4 plus 4, 8 oxygens. So I have 4, 2, and 2. So that's a total of 8. And hydrogens, I've got 8. 4 plus 4 is 8. So everything balances. So now I'm ready to add the 2 half reactions, but I have to make sure the electrons cancel. So I have 6 electrons on the right, 3 on the left. So if I just take my bottom reaction and multiply it by 2, I will have 6 electrons on the left. So I don't have to multiply the top reaction just by 1. It doesn't change anything. So now I'm ready to add the 2 half reactions. So I've got 6 OHs, 3 waters. Now some of these are going to cancel after I add them, plus bromine minus. And then on the left and the bottom, I've remembered to multiply it by 2. I've got 2 times 4, 8 waters. I've got 2 MnO4 minus. That's everything on the left side of the arrow. The right side of the arrow, I've got BrO3 minus and 6 waters and 2 MnO2s and 4 waters plus 2 times 4, 8 OHs. So now I'll see I'll have waters and OHs common on both the left and right, so I'll go ahead and cancel those what I can. So let's see, I have 11 waters on the left and 10 on the right. So that's going to give me 1 water molecule on the left. So I've canceled my waters. Now OHs, I've got 6 on the left, 8 on the right. So that's going to give me a total of 2 on the right. So now this is my balanced equation, simplifies some. So I make sure everything is balanced. I'm going to write it over up here on one line. So I have Br minus plus water plus 2 MnO4 minus gives BrO3 minus plus MnO2 plus 2 H's. Okay, so let's make sure everything balances. 1 bromine, 2, oops, I'm missing, this is supposed to be 2 manganese oxide. Had a typo there, so that's why I double check. 1 bromine, 2 manganese. Oxygens, 1 plus 8, that's 9. So I have 3, 7, 8, 9. So I've got 9 oxygens. Hydrogens, I've got 2 and 2. So all the atoms balance. Let's look at the charge. I've got a total of -3 on the left and a total of -3 on the right. So everything balances. So this is my balanced redox reaction in basic solution. So remember, in basic solution, the last step is to cancel the H pluses with OH minuses. So remember to add the proper amount of OH minuses to each side of the equation. And then we add to cancel electrons as we did before.